guys, we are still on our Unit 9 test review, but we are moving on to our third page, which starts off with Section 5 in geometric sequences. So remember here we've got a few different forms. We have the recursive form, which is going to be a sub 1 is equal to some value, and a sub n is equal to a sub n minus 1 times my r value. And then I'm going to have my exponential, my explicit formula, which is going to be a sub n is equal to a sub 1 multiplied by r to the n minus 1 power. So let's get into this. For my sequence, so I'm looking at my columns here. So column A, I've got 7, 14, and 28, meaning that my initial value, a sub 1, is equal to 7. And my r value here I can find by doing the second divided by the first, which is going to be 2. So therefore I have a sub n is equal to a sub n minus 1 times 2. Then for my explicit formula, I'm going to have a sub n is equal to that initial value of 7 multiplied by the r value of 2 raised to the n minus 1 power. So therefore my exponential function is going to be f of x equals 7 times 2 to the n minus 1 power. Now the next one gives us the explicit formula. From there we could directly write our exponential function because I'm going to switch a sub n to be f of x. I'm going to have 3 times 4 to the x minus 1 power. And I apologize, that should have been to the x minus 1 power on sequence A as well. Then I'm going to go to the recursive formula. My initial value, if I'm looking below, is going to be 3. And so therefore I'm going to have a sub n is equal to a sub n minus 1 multiplied by the r value of 4. And I could write my sequence by doing 3. And then 3 times 4 is going to give me 12. 12 times 4 is 48. And I could keep going if I would like to. And then if I'm looking at sequence C, my initial value is 5. And it looks like I'm multiplying by a negative 2. 5 times negative 2 is going to give me a negative 10. Negative 10 times negative 2 is a positive 20. So I'm just reversing my signs each time. Therefore, my explicit formula is going to be a sub n is equal to 5 multiplied by the change factor, or excuse me, the common ratio of negative 2 to the n minus 1 power. Or I could say f of x is equal to 5 times 2 to the x minus 1 power. And 15 is really just determining if it is a geometric, arithmetic, or neither of these sequences. So arithmetic is going to be adding, geometric is multiplying. So if I'm looking at this, to get from negative 6 to negative 1, I'm going to add 5. Negative 1 to 4 is adding 5. And 4 to 9 is adding 5 as well. I apologize for that, guys. So if I'm adding 5 each time, this is going to be arithmetic. You don't have to do anything else with it as long as you know the common difference is 5. Now, for B, I see there's a pattern here, but I'm not quite sure what it is. So let's just try to do R is equal to 40 divided by negative 80. So that gives me negative 1/2. If I multiply 40 by negative 1/2, I get negative 20. If I multiply negative 20 by negative 1/2, I also get 10. So therefore, this is geometric. And it looks like for C, if I do 6 divided by 2, that gives me 3. And it does look like I'm multiplying by 3 each time, so this is also geometric. In our next video, we'll go over applications.